Okay, so we've talked about the range, the variance, and the standard deviation. Variance and standard deviation are related, and the standard deviation and range are related. We just showed that with the range rule of thumb. So suppose we're going to compare body of weights of two groups of people, and we find that the standard deviation, which is a measure of the variation, right, for the first group is 3 pounds, and the standard deviation for the second group is 10 pounds. What can you say about the first group? Well, it looks like the first group's weights are a lot closer together than the second group, which has a standard deviation of 10 pounds. Okay, that's the conclusion that we can make from this. So if we don't know any other information, then it looks like maybe the 3 pounds for the standard deviation of the first group is a narrower interval. Most of the data points are going to be within, 3 pounds. Whereas the second group is going to be 10 pounds. Most of the data points, most of the weights of the people are within 10 pounds. So what if, though, I told you that the first group consisted of preschool kids with a mean weight of 30 pounds, and the second group consisted of NFL linemen having a mean weight of 330 pounds? Well, there's a problem here, and the problem is that you can't just compare a standard deviation, which is a variation, of 3 pounds to a variation of 10 pounds, right? Because your contexts are different. The means, the averages are very, very different as well. So, can you compare two standard deviations without knowing unit, scale, or context? No, not really. You need more information. Okay? Coefficient of variation is what actually comes in to help us with this, which is basically it's a measure of variation, but using a percentage. So when comparing variation in two different sets of data, the standard deviation should be compared only if the two sets use the same scale units and have approximately the same mean, the average. Bullet point number 2, if the means are very different, or if the samples use different scales or units, then we cannot use the coefficient of variation. So keep that in mind. Here's the formula for the coefficient of variation for a set of non-negative sample or population data. Expressed as a percent, describes the standard deviation relative to the mean. And here's what the formula is given by. It's basically a ratio between the spread of the data and the average of the data. Standard deviation, which is this S here, is divided by X bar and multiplied by 100. Okay? So that's the coefficient of variation. S, which is the standard deviation, is divided by X bar, the average. Let's go through an example. Suppose you want to compare the variation in heights of men to the variation in weights of men. You suppose that mean for the heights of men is 68.34 inches, and standard deviation is 3.02 inches. And then suppose that the mean for weights is 172.55 pounds, and standard deviation of 26.33 pounds. The question is, can you simply compare the standard deviations for the two sets? Why or why not? And you cannot, because think about it. One is a measure of the weights, and the another is a measure of the height of people. So cannot reuse the just standard deviation to compare the two spreads in the data. But we can find the coefficient of variation for each set and then interpret that meaning. Let's do that. Note that the higher the coefficient of variation, the greater the level of dispersion around the mean. And then weights vary more around the mean than the heights. We'll see that. Think about this. Well, actually, that last bullet point, think about people vary in their weight more so than their height. And that's what we would get if we divided standard deviation 3.02 by 68.34. And we get about 0.044, which is about 4.4%. And then do the same thing with the other one for the weights. we have 26.33 divided by 172.55, you get 0.15. So it looks like weights vary more. It has a coefficient of variation of 15%. That's a lot. Weights vary more than heights. And that, again, should make sense in the real world anyway. Go ahead and do this one as practice. The mean and standard deviation of marks obtained by 40 students of a class in 3 subjects, mathematics, science, and social science, are given below. Which of the subjects shows highest variation and which shows lowest variation in marks? Well, you can't just look at standard deviation. These are different. The context shows that we have these different 3 different classes. So the way to find the variation via a percentage would be 12 divided by 56, 14 divided by 65, and 10 divided by 60, and then multiply the result by 100, and that would get you the percentage of variation, and that's what the coefficient of variation is. Okay, in this slide here, what I'd like you guys to do is actually review. So you should be able to, hint hint on the quiz or test, you should be able to either describe or write the formula of each one of the measures of center and the measures of variation or dispersion. The mean formula, the mode, the mid-range, the median. You please note that some of these don't have formulas, they just have descriptions, like the mode is the most frequently occurring, right? But go ahead and take a moment, pause the video, and see if you can remember all of the measures of the center, measures of variation or dispersion as well, and write their formulas. Okay, in this next section, we're going to talk about measures of relative standing. Comparing two values in a data set can be a little bit tricky, so we have to be careful about that.